Hello friends, I was about to do a lab for a couple VRF Lite scenarios. Decided to bring you along. We can discuss the lab. In this case, I have customer A with their equipment, router 1, router 2, customer B with router 1, router 2 as well, and a common backbone. The idea is to separate the VRFs, the entire traffic. Notice how the IP addresses are exactly the same, 10.0.0.2, 10.0.0.2, and then 20s on this other side. And this will not interfere with the traffic from one to another, since they will be segmented in the colors that you see here. So far, the only thing I have configured is the routers, the customer routers with the IPs that you see here. Customer A router 1 with 10.10.0.2, 10.10.0.2 also for customer B. There is no routing for any of it, so do show IP route, nothing, only what's connected there. And then on the backbone, there's absolutely nothing. We have router 0 and 0.0, nothing is configured. The idea is that we're going to virtualize routers 0 and 0.0. We're definitely chopping it in half so that we can route the traffic from customer A into a sub interface where using this IP address in a sub interface with 0.0, so that we can reach all the way to the 20 segment on this side. And then the same thing for customer B without affecting each of them. We'll be using OSPF, two separate processes for OSPF, so that we can separate the two traffics. Right. So to get started, we will start by defining VRFs. Customer A. Exit out of that, repeat the same thing for customer B. And we have defined the two VRFs. Now we're going to assign that VRF to the interface. So interface G0/1 IP VRF forwarding customer A, and then proceed to add the IP address. For the side, it will be that one. I like to add OSPF under the interface. So in order to do that, we'll have to associate the process for OSPF with VRF Cust A, and this is case sensitive, so you have to be able to match it. Router OSPF to VRF customer B. Okay, so now they're defined. Going back under the interface, G0/1 OSPF IP OSPF 1 area 0 under the interface. Node shut for you. All right, so interface comes up. Let's go into router 1 and do router OSPF 1, and in this case I will do the network on this side. So network, I don't have to, just want to do it this way for this. 0.0.0.0, and it was a /24, so that makes it 255 area 0. Right, and the interface is already up on 0.0. The process for this side, remember OSPF, the processes don't have to be the same. So in this case, it should come up on its own. Show IP int brief interface, that one is up. You show IP OSPF interface brief. So the interface, it's already on OSPF. And speaking of the devil, it just came right up. Do show IP OSPF neighbor. There we go. Then so do show IP route VRF customer A. We have to add the customer A name VRF in order for us to look at the IP route. Remember, we're creating a different route, a different routing table. Notice there is no OSPF in here just yet, because the connected takes priority over OSPF. So in order for us to test that theory, what I like to do is I want to create a loopback interface. So IP address 1002, and then 255.255.255.255, and then we'll add this IP OSPF 1 area 0. And what this is going to do is add this interface into OSPF, and we should be able to see it up here. There we go. So we know OSPF is working on VRF for customer A. All right, let's do customer B now. We already defined the VRF, so we just have to go under the interface 02 IP VRF forwarding customer B IP address, same IP address. It will not mess up with our process since we already segregated the VRFs and we have already declared what the OSPF process and VRFs are. So I could do IP OSPF 2 in this case, area 0, no shut, and then go back over here and do the same thing we did before. So we'll do INTG 0 IP OSPF 1 area 0. Also, I want to add the loopback in here. So INT loopback 0 IP address 255.255.255 EOSPF area 0. Okay, so we'll check do show IP route VRF customer B customer B. Okay, so we do have a route for that. Customer A, that was operational. Let's see what happens here. All right, router OSPF to VRF customer B. Router ID, we'll do in this case 2 1. Okay, right, and then on this side we'll do router. There you go. Router OSPF 1 router ID. This is customer B, so we do that. Do clear IP OSPF process. Yes. Hey, and that should do it. And it says there's a detected a duplicate router ID. Do show IP OSPF 1. There it goes. OSPF 1. Do show IP OSPF 2. And I'm using the same router ID, so that's the problem. Okay, so router ID 2 1. Do clear. There we go. Do show IP OSPF neighbor. There we go. What about you? Do show IP OSPF neighbor. There we go. Full. All right. Do show IP route VRF customer B. Oh, so we got OSPF coming down this way. Show IP OSPF. We show IP route. Okay, only connected here. So we do interface loopback 0 IP address 1 255.255.255.255, and then we do interface loopback 1 IP address 2001 255.255.255.255 IP OSPF 2 areas 0 areas 0. Do show run section route. So we're still there. INT loopback 1. So we do IP VRF forwarding customer for loopback 1. Yes. IP address 10221 IP OSPF 2 area 0. Then interface loopback 0 IP VRF forwarding customer A IP address 1001 IP OSPF 1 area 0. All right, so now we should be able to see the OSPF show up here. Do show IP route, so OSPF here as well, right? And we have interface In this case, I want to separate the traffic on the backbone in two separate sub interfaces, right? So we'll take G00, and we'll do .10 encapsulation, .1Q10, and then we do IP VRF forwarding customer A IP address 110.0.125.255.255 and 252 IP OSPF 1 area 0. This we have already defined that. Okay, and then we go under create one more subinterface for 20 encapsulation .1Q20 IP VRF forwarding customer B IP address 100.0.1 with a 252 IP OSPF 2 area 0, and then go under the interface and no shut. All right, we should be able to see some of that traffic come up shortly. That comes up. Okay, eventually we'll get to see, there we go, 100 coming right up on this side, and this is for customer A, customer B. Perfect, 1 and 1. And let's do the other side. Same as before. First thing we have to do is define the VRF. So config T VRF IP VRF customer A, okay, customer B. Then we'll go under the interface, create the subinterface 10 encapsulation .1Q10 IP address 100.2.252, and then here I'll finish doing this before I do the defining and assigning the OSPF process and the VRF, since we haven't done that on this router just yet, right? Which it will be necessary to assign that. So we'll do interface G0020, and we do encapsulation .1Q20 key address 100.10.02.55.255.255.252, and then because we haven't defined the VRF, and that's the mistake I made. Before I do that, I have to also include the VRF in the subinterface, which is a mistake I made. So we do show run G0010. So this information has to come off from here once I add the VRF, and then put it right back on. So the way I'll do it, I'll copy this, and then I do IP VRF forwarding customer A, and that's going to drop the info. I'll put it right back on it. Go under the other interface 20, do show run interface G0020. Okay, so we take that is incorrect. 20 should be for IPVRF Bravo. So know this. Yeah, IPVRF 20 should be for Bravo. Then IP address 110.0.2.255.255.255.252. We show run INT G020. 20. Okay, correct VRF, correct customer and subinterface. Let's do check the other one. 10. This needs to go into a VRF as well. Interface G0/010 IP VRF forwarding customer A. Okay, so repeat that, see what just happened there. Okay, we lost the IP address, so we just go IP address 100.10.02.255.52. All right, we have IP and all that. We just need to focus on the routing information now. So router OSPF 1 VRF customer A. Okay, exit out of that. Repeat customer B and VRF. All right, back under the subinterface G, just the way I like to do it. IP OSPF 1 area 0. And just like that, we should have some OSPF once we turn on the interface. Okay, we should get some neighbors shortly. Do show IP OSPF neighbor. It's not running. Please configure the router ID, same as before. So process 1 came up. It requires the process ID for router OSPF 2 VRF customer router ID. In this case, I'll do, what do I do? 10.0.0.1 for router ID, and 001. Okay, and that should trigger the OSPF, and it does. Do show IP OSPF neighbor. We have two neighbors on .20 and .10. Show IP route VRF customer A. Here we have it. Customer B. There we have it. And now it's a matter of configuring the right side for the router to use. So IP VRF forwarded customer A. IP address 20. Assign the VRF. Assign the IP. Wrong VRF. Try to be lazy here. There we go. Assign the IP. There we go. IP OSPF 2 area 0. Check. All right. So do show INTG /1. Check. That is correct. That is also correct. Perfect. And now let's do customer routers. Section route. There we go. So interface is up. OSPF adjacency is up. Do show IP OSPF neighbor. Check. Do show IP route VRF customer B. But there's no VRF here. Do show IP route. Check all the way down to do ping. Let's do 2001. Check all the way across. Do show IP route VRF customer. Check both sides. Customer A. There you have it. All right. So now we have the capability of pinging from router 1 customer A all the way down to router 2 customer A, utilizing the backbone in between, utilizing this route, the specific route that was also added in this VRF, and they're completely segregated from customer A and customer B. So I hope that you enjoyed this lab. It seems a little difficult, but it's really not. Once you get a hold of understanding that you have to define the VRF first, then associate the interface with the VRF that you're trying to use, and not forgetting to use, if you're using dynamic routing like OSPF, you have to associate the process, the routing process, with the VRF that you're using for that process as well, so that it can actually work in conjunction. But just as you see it here, it is not that difficult, and you can do it just in a few minutes. All right. Well, thank you for watching.